Baby shawties, how we doing today? Welcome to our first video lesson on static electricity. Today we are going to introduce static electricity and talk about where the concept of charge comes from and how it relates to the structure of the atom. So within these next two units that we're going to focus primarily on electricity. So the first unit is going to be focused primarily on what's called static electricity. Static electricity is something you guys might have experienced at some point in your life. When you've rubbed your feet across a carpet, for example, and maybe touched a doorknob and received a static shock. So kind of what's going on here is, let's say I have John Travolta here, and I take John Travolta's foot, whoopsie daisies, and I rub that across the carpet. Notice that when I rub his foot across the carpet that he picks up those little blue dots. So little blue dots are going to represent that static charge that he would accumulate just by rubbing his foot across the carpet. And when you experience that static shock, what happens is that charge then will jump from his finger to that doorknob. So that is kind of the idea of what static electricity is all about, is that when I take his foot and rub it across the carpet, he's accumulating those little blue dots, and that's going to represent what's called a charge, okay? And that static electricity is all about what happens when objects accumulate charge and how that charge then affects the space around it. So that's what we're going to focus on within this chapter. So static charge is all related to the structure of the atom. So the atom is, and I'm assuming that most of you know what the atom is, but it is kind of our knowledge of breaking down the very small. So where this unit and unit next or after this is going to be a little bit different is that we're going to start looking at the very small part of the world we live in. So things that we physically cannot see with our own eyes, but we know to exist, or at least have theories on how these things exist. So the atom is first thought up back in the early BCs, 400 BCs, by a guy named Democritus. He thought of the idea of an atom by, if, say, for example, I were to take a piece of paper and split the thing in half, and if I were to take that half and keep cutting it in half, cutting it in half, and cutting it in half, eventually what I'm going to do is I'm going to get a really small piece of paper that's made of something. And what he theorizes is that all objects, no matter what they are made of very, very small pieces of matter, and he called those atomos, which is Greek for indivisible, which means that it is the part of an object that cannot be divided anymore. It's the smallest part of an object. And this is actually something that was thought to be a crazy idea that people didn't believe, and it wasn't until about 1808 when a guy by the name of J.J. Thomson first discovered one of our subatomic particles. It's a particle that's within the atom called the electron. And by discovering the electron, from there we were able to come up with the idea of that the electron is surrounded by some positive, what's called a nucleus. This was with the gold foil experiment, for some of you that might know from chemistry. Then we had Niels Bohr that came up with almost what's called the solar system model of the atom, where we have a positively charged nucleus and we have those electrons that orbit around like planets around the sun. And into our current model, which is the quantum mechanics model, which views electrons moving as both particles and waves. So it kind of gets a little sassy, but the thing we're going to focus on in terms of how things accumulate charge, our view we're going to use just to simplify things, we'll primarily focus on the Bohr look of the model, that we kind of treat it very similar to a solar system where we have a positive center surrounded by negatively charged particles. So understand that the atom is going to be our basic building block of everything. So whether you break down whether it's a piece of paper, like I said before, whether it's a human being, no matter what it is, that we can break anything down into its basic properties called atoms. Okay, and it depends on what we're made out of. So for example, we could be made out of water, for example. And we know that water is H2O, right? So H2O means that it has two hydrogens and one oxygen. So it's made up of two atoms, hydrogen and oxygen, okay? Now, every atom is going to be slightly different. So this is where you get, like in chemistry, your periodic table of elements. But the basic structure is this, is that an atom has that positively charged core called the nucleus. And the nucleus is where you're going to find both the protons and the neutrons. Those are called the nucleons because they live inside the nucleus, okay? So you got the protons, which are the positively charged particles, and then you have the neutrons, which is just a particle that lives inside the nucleus to give mass. Now, think of neutron. People sometimes confuse neutron with a negative charge, but think of neutron as the charge that's neutral. So it doesn't actually have a charge to it. But we do have then the last one, which orbits around the outside, which is called the electron. And the electron is going to be that very tiny particle. It's very similar to the planets in a solar system, and the nucleus is very similar to the sun. So notice the relative size. Protons and neutrons are much, 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 much bigger than electrons, and electrons are floating around the outside, which is why, if you think about the electron was discovered first because it is what's floating around the outside. And it was not until later that we actually found out that the nucleus composed of all these other particles. So when it comes to charge, here's the idea. This looks very similar, again, like I said, to a solar system. So a solar system, we have like the sun and all the planets. And what we know is that there's that force of gravity that keeps all the planets in orbit around the sun. And that gravity is created by mass. So when thinking about the atom, you have these little tiny electrons that are orbiting around like planets. Now, these objects are so small that the mass of those objects does not make a difference. So the force of gravity really doesn't exist at this very small level. So there must be something else that's pulling them together. So what we came up with is that the protons in the center and the electrons around the outside, that these two things have what are called charge. That we gave them essentially an opposite charge, that protons are positively charged, being in the center, and electrons are negatively charged. Now, where this comes from is that in any given atom, that the number of protons and number of electrons normally balance each other out. This is what's going to be called neutral. A neutral atom, you'll see here, has, in this case, 8 protons located in the center, and then we have 6 and 2, 8 total electrons that are orbiting around the outside. So notice there's a balance there. Same thing, you can look at neon. We have 10 protons, 10 electrons. We have, with sodium, 11 protons. If you count those up, you'd have 11 electrons. So for every proton, there's an electron there to balance it out. So that's where the concept of charge comes from, that you have that positively charged core surrounded by those negative charge electrons. And again, the amount of protons, the amount of electrons are always going to balance each other out. So when we talk about charge, we want to look at things having, let's say, a negative charge versus a positive charge versus being neutral. All objects in nature tend to be neutral because their charge is going to be balanced, because the number of electrons and protons will be the same. If we have something that's negatively charged, what that means is there's going to be an excess of electrons. And if something is positively charged, what that means is there's going to be an excess or an unbalance of protons. Okay? Now, when it comes to the structure of the atom, know that the electrons orbit around the outside, kind of like in a cloud, where the protons are glued to that center nucleus. So when we talk about the charge of an object, like let's say I wanted to charge John Travoltage, when he gathered those blue dots, what he was doing was he was gathering, and notice they were labeled as a negative, he was gathering electrons. And the reason being is that electrons are floating freely around the outside. So it's easy for us to remove an electron or add an electron into the atom, but it's very, 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 very difficult to remove a proton from the nucleus. It'd be like us removing a planet from the solar system, which may not affect too much, versus us making the sun a different size, which would extremely change the world that we live in. Okay, so when it comes to charges, we have 3 types: positive, negative, and neutral. Negative charges, what we're going to define this as, is to be an excess of electrons. So notice it's all about electrons there. So if we count this up, we would have here 5 electrons compared to 3 protons. Positive, sometimes people think positive means to have an excess of protons, which is technically true, but the way we're going to view this is having a lack of electrons. So the key thing when it comes to negative charges versus positive charges, it is all going to be about the number of electrons, because electrons can be easily removed or added to any sort of atom. And again, all objects in nature are going to tend to be balanced. So that is what all objects are going to be or want to be. So if something accumulates a charge, it's going to act in a certain way to try and gain neutrality. It wants to be neutral. Okay, so charge is all based upon the number of electrons you either have or don't have. So if I have an excess of 10 electrons, that if I were to know the charge of one electron, I can figure out my overall charge. Same thing were true if I had a lack of 10 electrons. If I knew the charge of one proton, I could find my overall charge. So it was discovered through experimentation that charge has a fundamental value to it, that every electron and every proton is going to have the same amount of charge. And that is going to be a value of 1.6 times 10 to the negative 19th. And then we have a new unit. It's called a coulomb. Okay, so coulomb. Think of cool. Okay, labeled with a capital C. So this is like, almost think of this as like the kilograms for charge. It is a basic property of objects that accumulate a charge is described in how many coulombs it would have. Now 1.6 times 10 to the negative 19th, this is what that number would look like. It is a very small number. Okay, there are 18 zeros there because I had to bring that one extra spot, but there's a very small number to represent the charge of a single electron or a single proton. Okay, why is this number so small? It's because electrons and protons are very small. But this is what's called the fundamental unit of charge. It is a charge of a single electron or a single proton. So, kind of show you this table. Our three subatomic particles are electrons, protons, and neutrons. Okay, so electrons, again, are going to have that negative charge. I also show here the mass. So the mass of an electron is 9.1 times 10 to the negative 31st. So that is extremely small. That's how many kilograms it is. And then how many coulombs it is. So notice 1.6 times 10 to the negative 19th, and it's a negative charge. A proton, mass-wise, 10 to the negative 27th. So that's an order of 10, times 10 to the fourth, bigger than an electron. So mass-wise, a proton is much bigger than an electron, which is why it's found in the nucleus. However, charge-wise, the charge of a single proton and a single electron are going to be the same value, just opposite. Electrons negative, protons positive. And the reason why they are the same identical charge is, again, think about the simplest atom we can have, which is hydrogen, which would have one proton and one electron. In order for that electron to stay in orbit around the proton, it's got to have that same, kind of like gravity, it's going to have that same amount of charge that's going to be pulling on each other to keep them in orbit. The only difference on why the proton doesn't move is because it's much more massive than the electron. And then notice our neutron is simply a mass giver. It gives mass to the nucleus, but has nothing to do with charge. Okay? So when we look at the charge of an object, what we're going to do is look at its imbalance of protons and electrons. So say I had an atom that had 5 protons and 6 electrons. If I know that there's an imbalance here, I know that this has 1 excess electron, okay? So if it has 1 excess electron, I know that it's negatively charged. So to quantify this, which means fit a number to it, if I know it has 1 excess electron, I can take that and multiply it by that fundamental unit of charge. Now, I'm not going to put the negative on here, I can, but I already know it's negatively charged. But if I multiply that, I know that that object would have 1.6 times 10 to the negative 19th coulombs of charge. So I can fit a number to it. Okay, so say if I were to have 6 protons, 4 electrons, again an imbalance, this would be a positive charge, and know that there are a lack of 2 electrons, which means that there is going to be a surplus of 2 protons. So I would take 2, which is the number of excess or lack of that I have, and multiply it by that fundamental unit of charge, 1.6 times 10 to the negative 19th. And that would give me 3.2 times 10 to the negative 19th coulombs. So it gives us a way to quantify things. Now, obviously, these numbers are very small because we are only gaining a single electron or losing 2 electrons. So this would be what would happen at the atomic scale. If I were to look at things on the larger scale, we're going to gain a lot more electrons than just 1 or 2. We're talking maybe millions, billions, or trillions of electrons that are shared between physical objects like John Travolta's foot rubbing up against a carpet. John Travolta's that's tough to say. All right, same kind of example, just going to use bigger numbers here. So now let's say that we have Randall that rubs a plastic rod with fur. It says the rod here gains 10 extra electrons. So key thing, if it has 10 extra electrons, I know that it's negatively charged. So to find its overall charge, I would just take that 10 electrons at a value of 10 and multiply it by that fundamental unit of charge. So 1.6 times 10 to the negative 19th coulombs. And that would give me 1.6 times 10 to the negative 18th coulomb. Just take away a value of 10 there. Okay? Now it wants to know what's the overall charge on the fur. So know that if the rod gains 10 electrons, then that means the fur must lose 10 electrons. So it's going to make it, whoopsies, positively charged. So if I want to find its overall charge, I'm going to end up just taking that value of 10, like we did before. I don't know what's going on here with my pen, folks. I would have 10 times that value of 1.6 times 10 to the negative 19th coulombs. My pen's all sorts of jacked up, and that would give me the same answer that I have here, just a positive 1.6 times 10 to the negative 18th coulombs. Must have to charge my little pen here, folks. But again, this is looking at the idea of charge and how it's related to the atom. What we're going to investigate next is how charge interacts with each other and how it interacts with the environment around it. Guys, have any questions? Make sure you jot those down. Otherwise, we'll see you in class. Peace.